Hello and welcome, all you awakening genius problem solvers out there. Let me know how my audio is doing. Hello, beautiful souls. We love learning. Yes, I love learning too. And today was the last day of the 2022 Offshore Wind Power Conference and Exhibition here in the ocean state of Rhode Island, which I got a last minute press pass to and was able to attend and get some awesome pictures and get some awesome interviews. And I learned so much in the last 2 days. This is kind of off the kilter of what we usually, do and normally talk about on this channel, but it's not outside the wheelhouse of what people are interested in. Biden is pouring billions of dollars into offshore energy, wind energy right now. So, wow, I just watched our view count number drop. It was at like 50, and now it only says 6. This is pretty interesting. Biden's pouring billions of dollars into offshore wind energy, so there's tons of money out there right now. They want to build wind turbines. They're not windmills. People have been calling them windmills. A windmill grinds grain and pumps water. These are wind turbines, and they're much bigger. Some of these blades on some of these wind turbines can be 2 football fields long, and they can generate up to 15 megawatts of power on some of these things. We don't have the infrastructure to build that big here yet in the U.S., and I'll get to that, but they have a lot of this infrastructure already over in Denmark and Germany, where they've been pioneers in the wind energy industry. And there were a lot of groups and a lot of people there at the conference from Germany and Denmark. So without further ado, I will first get into, all the cool, awesome swag that I picked up, just from all the vendors that were there in the exhibition hall. So we got American Clean Power, safety campaign. A lot of safety guys there offering training, ropes, training, maritime emergency training, navigation training. That down at Mass Maritime was there. They offer it's a maritime college here in down in Buzzards Bay in Massachusetts, on Cape Cod, and they do a lot of they train like sailors and a lot of nautical people who want to do boat related careers, and they train a lot of captains and other things. So I met a captain there. These guys, New Jersey Offshore Wind, were there. Apparently New Jersey's got some wind energy projects going in. So doesn't North Carolina and Virginia. So they gave me an awesome beer koozie, which I will take full advantage of right now. Yes. We have the rigger guys. They gave me an awesome fitted hat. These guys, Blue Water Shipping. There's a lot of boat companies and dock companies that actually run the harbor masters, Port Authority. Different people that actually just run the docks and stuff to where these operations are going to be run out of. Large scale barges carrying huge heavy equipment out to sea. These guys even gave socks. They made socks, dude. So I got a pair of socks. Cool. I basically walked around the exhibition hall and I was checking stuff out, and whoever said hi to me, I would stop and talk to. And I promote them on the stream and talk about what they were there and what I learned. So these guys offer training down in Houston, Texas, and Houma, Louisiana. They said that the place in Houma, Louisiana is like the coolest spot, and there's a ton of awesome guys there. It's actually the Marine Fire Training Center. They train firefighters for the Marine Corps. Pretty awesome stuff. Connecticut Port Authority, where they have some of these projects going out of. They got these massive wind turbines on the docks, ready to be shipped out to sea and installed. New Jersey Wind was there talking about building the clean energy future. This was actually a coloring book for kids. I got 2 of them for my kids so they can learn about wind turbines and how we're harvesting natural wind energy and turning it into useful electricity that we can use to run our homes and computers and internet and live streams and all that great stuff. These guys do geotesting. Now, this is an awesome company because they're right here actually in Massachusetts. I think Acton, Mass or something. So these guys do soil, rock, and geosynthetics testing. So if people have, I know there's a lot of people that are into like geology and the idea like the pyramids and all those geopolymer theories and stuff. Well, these guys will test your rocks and give you just unambiguous, unbiased data. You don't have to tell them where they came from. They'll tell you. They'll tell you exactly what you sent them. So those guys are awesome. Yeah, people geotesting.com. And yeah, there might be some people out here that want to send samples and hire a professional laboratory for use in geology testing. There are also these guys there, Blaced. A lot of controllers, switcher and control companies, which we'll talk about. This was Beckhoff. Beckhoff was there. I talked to that guy for a while. They had some interesting automation technology, which I'll show some pictures of here in just a minute. And then, of course, like the PC control, a lot of control systems people there. That's actually how I got my foot in the door at the conference, because I went with my father, who works for an automation research corporation here in Massachusetts, and they were there, to write an industry report on, how much money an estimate of how much money there is to be made in the automation industry, within which chunk of that, these tens of billions of dollars that Biden and the government and all these oil companies, a lot of oil companies actually sponsored this event, because some of the oil companies, not all of them, Shell in particular is being very environmental and trying to change its image and putting a lot of money into these alternative solutions for what we need to start curbing our addiction to oils, but not so much like ExxonMobil and stuff. From what I've heard from just chatter and banter around this place. So yeah, let's get into the pictures and the photographs. I'm gonna start showing off some photos of the event. I know some people might find this boring. It's a little bit different, and we're kind of switching gears and stuff. But I learned a lot about wind power and wind energy. And to all you free energy people, who want to compete with wind power for a power source, by all means, show us that you can get the megawattage that some of these things are producing, and we'd love to see it. This was Jennifer Daniels. Number of people from this was he's a legislator. A lot of government people there talking about create the job creation, and whatnot. I wish I had all these people's names in front of me. I don't. Should have written them down. Yeah, they had a conference. A lot of women in the industry. Shell is actually trying to make 40% of its workforce female, and they're hiring more women than ever. And so they had a panel that talked about that. I thought that was interesting, with some female industry leaders in the wind power industry, and we talked to a few of them. Milwaukee was there, of course. They make a lot of power tools and stuff. The state of Virginia Energy was there. They have a bunch of people from Virginia that are interested in expanding and doing cross business, just cross pollinating businesses, because this infrastructure already exists a lot, and it's getting built up. It's $1 billion industry that's basically just lifting off the floor grounds right now in front of us, and all these companies are trying to get a piece of it. This torque system, these guys, the ERAD Blue, these things look like damn freeze rays. They look super cool and high tech. And I guess they link to these this box, which you can set the torque exactly. And I learned a little bit. There was a lot of other torque guys there with some more interesting ideas and equipment too, which I'll show videos of and get into here tonight. Lots of cool places. Kent, delivering lowest LCO through technical excellence. So these guys do consulting and advisory, and a lot of people trying to get a piece of that. These a few companies, only a few companies there make these undersea cables, and these undersea cables are really interesting. I learned a lot about those, and had some interesting questions about those. These guys are the experts in them, man. I mean, this is a diagram. I don't think they have any pictures of anything that large actually going in, but man, they show this. It's like Moses splitting the seas and putting this giant cable under the ocean to bring power from these offshore wind turbines to the shore. Interesting. Then some of these gadgets that these guys have built for tools for bolting technology, because I guess there's a lot of bolts in these windmills as they bolt the pieces together to erect and assemble these things. So it takes a lot of the workload out if you can build machines that assist you with the bolting and are fast and efficient and effective. And it would be cool to get all these bolting guys down together and show off. Have a John Henry style race of whose technology is the best. That would be pretty cool. A lot of lifting and rigging guys there, like the rig rope access people. That those were right next door to this LiftX guys who sell slings. They didn't talk to me, but they had an interesting table. But I'll show the videos later. All these things were cool, man. They have these concrete blocks. These are just like small makeups of the big things that they can, produce with these concrete form. They have these concrete forms and blocks that they can. It's just so cool what they can do with these for natural landscapes, to put around the turbines and the bases of the turbines and stuff. So, these cabling ships. So, we mentioned those long undersea cables that have to go under the ocean to bring the offshore wind power to the shore, and the cables have to be. They're huge cables. I mean, these things are just massively thick. So they coil them up in this turntable, literally like a record player, and the whole thing spins and moves around on the ship, and has the gateways, so they can load the cable up through a winch, and then crank that winch down and pull the cable up and start pulling it, spooling the cables through. It's these massive cables, and I just thought that was so. The size of the ship, the mock-up models and stuff. I thought that was awesome. Nexans electrifying the future. Cool company. Then Phoenix Contact was there, and this guy Lance actually knew my dad, because my dad's big in the industry of all the automation, which are these controllers and stuff. And talked with them about some of this contact equipment and these these relays and switchers, and these equipment for this is like industrial process control system equipment. And these are, controllers. This thing acts like a computer. Ethernet cable comes in here, and they run a whole bunch of these controllers off of that. And so this can take data from external sources and then process it right here on the board. So this would be like the emergency shutdowns on, if the fan gets going too fast, or, certain wind conditions are too strong, they'll actually apply the brakes and shut down the fans. And these control boxes would handle all of that switching.
Perfect. There we are. Then you take this one. Yep. Put it inside. Load the gun.
Yeah. So this uses a battery tool. So it's actually a spring inside of there. So you put that in, just push it in firm.
That was sick.
Yep. Like that. And then line it up. There's a little bit of a bevel on the end, so you'll be able to line up, know when it's in the hole. And then just hold the tool down, push it to the surface, and pull the trigger. And that's it. That's it. So
it's weird because the actual blast of that gun was way louder than that recoil noise that pulled the spring back afterward. And all I could, in the audio that picked up on my camera, I didn't hear the actual blast. I only heard the recoil noise of that pulls the spring back in this. But it actually shoots this bolt in. It's a little bit bigger diameter than the hole that you drill. And because it's bigger diameter and is forced in there with such momentum from that spring, what it does is it friction welds these bolts in, and these things can actually hold up an F-150 truck. That's how much force that these bolts can hold with just that little bit of surface area that's plugged into there. And I actually have one of these bolts right here with me. The guy gave me one, so right here, and it's just got this little tip on there with this rubber neoprene. It's actually a neoprene washer, and that washer actually flattens out and creates a watertight seal so that elements can't get into this and affect where that that friction weld took place, so it won't erode over time. And then they have another system where they can pre-score the metals for attaching electrical contacts, because if you wanted to bolt your ground onto the wall here, you could there's a different nut and a system for doing that. You pre-drill it and then attach this thing, so you can literally you can bolt all your stuff right onto the walls of these wind turbines and stuff. So I thought that was super interesting. Cool stuff. Let's keep going. So, oh yeah, these guys were Blue Water Shipping. Those are the guy. That's the guy that gave me the socks and the hat. And they handle the boats, and also the heavy rigging to move stuff from dock to harbor to destination. So then there's this guy who does abrasives, selling discs and talking about, demonstrating, we got the best abrasives, so that you gotta. It's all about the industry, the work that needs to get done, and the iron workers were there as well, from the local iron workers. They do they're union guys. They're real big about the union guys doing a lot of this work. So it's going to be a lot of the iron workers doing the bolting and the prepping and running that kind of stuff. So there are definitely companies there trying to cater to those types of businesses. More bolting technology. So these things go up to like 1,200 foot-pounds. Some of these, the torque on some of these things. So they have these reaction lever arms that they can use leverage off, because there's no way you're going to hold something and do one of these 40 millimeter bolts with 1,200 foot-pounds of torque and hold that thing with your arm. It would rip your arm right out of the socket with that much force. So this is learned a lot about that, and I want to show you. I'll show you another bolting technology in a second. A video demonstration of another fast torquing technology, which I thought was really awesome. A lot of these guys with data and geospatial, like offshore, navigation that hook up. One of these guys was showing me the whole system that they have. It wasn't this guy. I'll find the guy when I talk about that. It was a guy. This is Max Maritime Academy. This guy's a captain who trains a lot of the engineers and mechanics and the iron workers who go out offshore to work on this stuff. That he's the one that trains them in survival rescue training and how to survive out at sea. And there was also guys with wetsuits selling wetsuits and stuff there. Yeah, the New Jersey Office of Economic Transformation. These guys were there too, promoting, cross pollination again, New Jersey and Virginia, trying to generate these businesses and these contacts and stuff. So I thought that was cool. Just a ton of people just schmoozing and hanging out in the lobbies and the areas outside the conference halls and stuff. Lots of people meeting and networking, and a lot of people from government and policy and decision makers, like yes men, and I didn't really see, like, besides the iron workers, I didn't see anyone there that was actually going to do work and build and work on these things and build anything. These were all just the people that are trying to set up businesses and business people and vendors and salespeople and government people. It was certain, and the people that offer the training. That was like the next closest to the actual workers who are actually going to build these wind farms. Sika, they make some interesting products. So they got a line of specific, sealants and caulks and epoxy resins and glues that they make just for wind turbines and the wind turbine industry. These guys were real super nice and awesome. This guy was super cool to talk to. So they were wicked nice and knew a lot about the industry and stuff. So I learned a lot by talking to just people and walking around. I'll show the whole walkthrough video that kind of goes over all the vendors. This was the Beckhoff guys. They do some more of the automation and control systems, switches and stuff, and have their own cable and link system. So a lot of these things do the same kind of stuff, but they're just different systems, different ways to skin the cat. And so we were mostly there reporting on this and that kind of stuff, like the Phoenix Contact and Beckhoff and IEP, which we'll get to in a second as well, with some of the interviews that we did. These dudes were super cool too. They make gearboxes, so they have to have a gearbox on this wind turbine to take the wind energy and then gear it down for the electrical generators and stuff. So they make these in the U.S. up in Washington at a plant that they have up in Washington State, and they can only make gearboxes up to 5 megawatts. So that anything bigger than 5 megawatts, so like the biggest I think they have like 15 megawatt gearboxes, and they have to make those at a facility over in Germany. They do not yet have the infrastructure to make gearboxes that big in the US, and they're one of the only people that make these gearboxes for the turbines, and they're all the way in Washington State, which doesn't do us so much good out here on the East Coast. So there's a huge need for companies on the East Coast that make a lot of the infrastructure that's going to need to supply these wind farms and the maintenance on these wind farms once they go in. So there's a lot to think about there. A lot I learned about the deficits in the industry. And these guys that do lighting, offshore lighting and lights systems that can and signaling systems, so that they also have ones that detect airplanes and can tell it when there's, they can keep it's to keep your wind farm safe so that boats don't crash into it or airplanes don't crash into it. So they have lights that they can they have detection systems on the windmills that will actually detect airplanes and activate, signaling lights to warn aircraft and ships. Same thing with boats and ships. And Bachmann Electronics, yeah, these guys are another control systems guys. They do control systems engineering. Super interesting. Then, yeah, we went back to these Nexans guys and talked to them. These guys are experts in the cabling stuff. This guy's from over in the UK, and this dude I think is from Texas. A lot of people up here from Texas in the industry. But they make the cables and they lay the cables and do the whole the cabling systems. And there's a lot I learned about the cables in general. Some of these things they have a handling temperature like 90 centigrade. The cable will heat up to 90 centigrade. That's almost boiling. I thought that was kind of crazy, but I'll play some of these interviews in a second here once we get into it. There's a lot of just business people there discussing policy and how do we push this through and what are the impacts and the downfalls and the setbacks and the a lot of interesting panels that they had and discussions that went on at this conference. But again, the vendor area, I was more interested in the hardware and the equipment and stuff that was being shown off. This was a company called Feisterer, and they do cabling solutions up to 550 kilovolts. It's pretty serious. And then the Hilti guys in the Oakland systems, they make all the rack mount stuff that can bolt. So this was the system to bolt these things onto the wind turbines, and these are all the racks that you can use to run your cables or what have you from the wind down the wind turbines. Really interesting stuff. Some stuff that goes into this, but a lot of market shares to be had here for that multi-billion-dollar market that just opened up with all the government money pouring into this, and then all these people there trying to figure out how to spend it all and where to spend it all, and then other people there trying to figure out if trying to get them to spend it on them and get a piece of that market share. So definitely interesting. Vaisala, WindCube. These guys have some interesting physics with this WindCube system. It's a LiDAR. It actually shoots lasers up into the atmosphere about 300 meters, and then measures the backscattering of that laser to calculate wind data and environmental data. Barometric pressure, temperature. It can tell basically everything about the atmosphere in that local area, just with LiDAR lasers that are inside this little WindCube. Yeah, the first day there was a ton of people there, and then just people hanging out in the lobby, and people checking out these boats. I thought that was try to capture some candid moments of just stuff going on. So this one, yeah, we'll go in here, and I'll start showing off some videos. All right, let's see if I'm gonna if I can share the screen and share the audio too. No. I can do this. And tell me if you can hear this okay. So we're here with Tom Macy of the Max Pro Corporation. He's got some rad looking, what are these, laser guns?
So what we have here are
Freeze-ray?
E-rad and B-rad torque wrenchers. Okay, these are high capacity, critically torquing torque tools made by Rad Torque out of Abbotsford, British Columbia, Canada. This is the E-rad 2,500 foot-pound electric torque wrench. It's capable of torquing anything up to 2,500 foot-pounds. These are also available in much larger and smaller sizes. We work with a wrench, cable, and a control box, and everything is controlled from the control box right here.
Oh, wow. That's a serious drive on there.
It's a 1-inch drive. That goes a 1-inch drive. That typically, we're doing like it's up to 2,500 foot-pounds. Common tool use in the industry.
Awesome. I was expecting you to point it and say freeze-ray, but it's a pretty awesome looking thing, man. Thank you for sharing that.
Is there a battery in here? No, this is purely electric. This is 100. You can buy this in 120 volt or 220 volt.
Wow.
This is a battery tool over here. Yeah. These are battery tools.
I can imagine a battery's not going to last long with that much power.
It'll last, yeah. It'll last all right. Usually about 100 rundowns or so.
That's at that's 100 rundowns at 2,500 foot-pounds. If you lowered the torque on that to like 300 foot-pounds, I'm sure you could get like 800 runs out of it. So
Was a cable by going with DC.
Well, it depends on the distance, on the long distance.
And sometimes that distance is less than 20 miles or so. And I'm a market analyst.
Yeah?
So I write about all kinds of things.
Yeah. Now, DC is more designed for long distance, above, say, 50 clicks, 60 clicks, kilometers. And AC, the majority of export are AC.
Vineyard Wind and Mayflower Wind, they have high voltage DC for like 20 miles.
No, they're a bit longer than that. Mayflower is longer than that. A lot longer.
They switched over. I think there's AC down to awesome. Maybe Vineyard was that, because I remember
Vineyard are doing AC.
I was surprised to see how short a run the DC was.
Mayflower, if you look at the Mayflower offshore converter platform, it's a lot longer.
Where do you
than
make
20
it? You had a place in Virginia or someplace?
are you guys local here? I know they do a lot of
This is
manufacturing.
in Korea.
Oh, Korea.
These are South Korea, all of these.
I know they have.
Pretty good.
Yes. Nice to meet you. Nice to meet you. They did a speaking engagement and we're talking about awesome. I spoke on the future of electric power generation. I had a speaker from NewScale. I had a former commissioner, Neil Chatterjee.
Okay, right.
I couldn't get him there physically, but I interviewed him and recorded it, specifically for the conference I had.
I'm gonna play my dad's those are kind of for his company. I filmed those interviews for him to make a tidbit for his company that sent him there. So I'm just gonna do the interviews that I did personally and the people that I talked to. So I'm here at the 2022 Offshore Wind Conference at the Rhode Island Convention Center. I'm here with Mikkel from the Force Technology Group. This is a professional service for the wind industry, and you guys do a number of things, but the main one you guys were telling me is this these floaters, these offshore floating wind platforms, actually.
Exactly. What you're seeing here is the future. At one point, we need more space for placing wind turbines, and you need to go further out, deep waters. These are made for waters above 50 meters. So you simply need a place, a platform where you can put on the wind turbine. So we are a model test facility. We have a towing tank, we have wind tunnels, but we do testing of all kind of floating structures, including such as these ones. So at this moment, we see a rise in the industry and demand by many places. So that's why we're trying to showcase our facility here in the US as well. We're hearing that it's going up mainly in the West Coast, but also we hear in areas here in, for instance, Maine.
Yeah.
They're looking at some
There's
floating.
a lot of good energy at deep water locations. So, what are these made out of? Is this?
I mean, this is just a display model. I call it a conversation starter.
Yeah.
But this one I have 3D printed. Normally it's a steel structure, all of it. And, of course, it's floating. You have the mooring chains underneath in various configurations. And that's what the Holy Grail is about, finding the most feasible design and seeing how to make it the best cost effective and the design that can withstand the most waves and the weather. So that's basically it.
Yeah, I mean, this thing doesn't tip over. You tried it in rough seas, and you try. I mean,
yeah. I mean, we do testing of our clients' designs.
Yeah.
So we just reflect the truth of what's going on.
Yeah.
So in our facility, we can make waves up to 90 centimeters.
Yeah, my dad was talking about that too. The Russians making the nuclear power plant barges, and talking about how by law or whatever you have to have 4 operators managing the control system on every single shift, 3 shifts a day. So in certain weather conditions like hurricane or super rough seas and stuff, you have to evacuate these facilities. And so how do you get around that? Like, can you build a control and shutdown system that's safe enough to be handled electronically and independently without a controller there? Without people there to monitor and who are trained on those systems and stuff. So it's super interesting. But yeah, about these designs, because there's got to be a different design for that you could come up with for these. This thing has 3 big floaty, buoyancy pontoons, and the windmill on one of those. And what's the best, most economic way to build a floating windmill device? And is there, any science to this? So that's some design and mainly testing. You got to put this thing in a swimming pool and put it to the max and stuff. So I don't know. It's there's some problems because I guess half the Pacific, right? So the Pacific drops off because of the San Andreas Fault, right? The whole side of the Pacific Ocean just drops off. So it's all deep water on the West Coast. So if West Coast wants to do offshore wind, they have to use these types of technologies. They don't have the option. They don't have these, a lot of that coast, like we do over here on the East Coast. So Rhode Island is an ideal place for the wind farms and stuff. And let's just keep doing this.
I'm Justin Ford. Charles Haymaker. Charles, nice to meet you. Lucas. Lucas, good to meet you. Kurt. I think we got a meeting with you guys. Yeah. You guys on here? Yes. Yes. Yes, we've been talking. Yeah, Vineyard. Might be tomorrow. Yeah, I was gonna say we've been talking on.
Those guys are serious. They do the shipping. Awesome.
And so, if I wanted to go to your training, and what would it be, like 2 years, 3 years?
So the basic safety training is actually delivered in 3 days.
3 days.
Well, this by no means makes you an offshore wind technician, but it gives you the tools that you need to be able to work safely out there.
Yeah.
So we cover some of the hazards that are included or involved with working offshore and what the best practices are to mitigate those hazards. We cover things like working at heights, first aid, fire awareness, manual handling, and then what makes it particular to offshore wind is the sea survival.
Sea survival, yeah.
Right.
Yeah.
So if you ever found yourself having to abandon ship, you would have an idea of some of the resources that were available to you both personally and on the vessel to enhance your chances of surviving.
That's good to know.
Good to know.
I've done a lot of construction and never been out on a boat doing any kind of construction out on out on the sea. So it would be good to get some kind of training and safety, and knowledge and awareness before I, to join a workforce like that. So,
sure. A lot of the skill sets onshore are the same as offshore, but now you're just dealing with a much more hazardous environment, much more isolated environment. So the companies recognize the value of CWO training, and they're requiring it of most of their employees because of the isolated nature.
So I was an employee for going out on the platform. They'd send me to Mass Maritime for a 3-day course, and to get training from you. This is how it goes?
Yep, we would certainly be able to deliver that training. Our partners in New Tech are very good at it as well. So depending on where you are in the country, but we've trained over 200 participants so far.
Nice.
And
and they've all survived so far, right?
That I know.
Okay.
Yeah. No, I mean, yes, of course. but they also have the ability to apply those. They never know when they're going to apply those skills. We had somebody from the pile drivers union take our class and in first aid, and the week after he completed his training, he was at home having dinner with his dad, and his dad had a heart attack. He was able to give him CPR and saved his life.
Wow.
So
On and off the job.
You just never know what's going to happen, and we were really touched to kind of hear that, and that his training made a difference.
That's a good story. That's a heartwarming story.
Yeah.
So you guys have 3 locations. Buzzards Bay, that's where you're from.
Yes.
Professor at Mass Maritime and a captain.
Yep.
And then Houston, Texas, and Puma, Louisiana.
Correct. And those are Rely on UTech locations.
Oh, all right.
Where they offer that training down there. So yeah, we're one of the few providers in the Northeast that's doing this training. We're definitely the first in the regions, and we're going strong and happy to be a part of the industry.
That's awesome. And apparently that Houma, Louisiana is the best place to do training, is what everyone's saying, that I heard. Do the cube. We talked about the cube. You guys want to learn about the these guys. There's so many. I'm going to show them all.
So I'm here at the Offshore Wind Conference, Rhode Island, 2022. And we're talking to some of the representatives from WindCube Offshore. So
That's the product.
So we're actually with Vysela. They're the manufacturer of the WindCube. And what else do you guys make besides WindCubes?
We're making a lot of different wind cubes.
Lots of different WindCubes.
Yeah, so it depends on the type of campaign you want to do, the application. We have onshore and offshore vertical profiling lighters, we have skinning lighter devices, and cell-mounted lighters. Each of these lighters can do different types of things and applications, and basically it depends on your project stage and the type of measurements you want to do.
Yep.
So we are basically supporting clients throughout the renewable energy life cycle.
And this is just for measuring, or is it's for monitoring and testing, or is it what else? What's inside of here?
There is a
There's
laser
different
chain
ones.
inside, which basically the laser engine that helps to do the wind measurements. So we basically send a laser signal to measure it basically backscatters from the particles in the atmosphere.
Mm-hmm. Like
And
Doppler.
and we're measuring the Doppler shift to understand the wind the wind direction and wind speed. So this is on
It's
the
like
lidar side.
LiDAR Doppler, laser Doppler, though, right?
Yeah. Exactly. Yeah.
Yeah.
And then we have also.
I love it when people try to dumb it down for the layman, and I'm like, yeah, I have a degree in physics. Like, I really want the complex explanation, and it takes like forever to get it out of them.
Other types of weather sensors to measure different atmospheric conditions.
Barometric pressure, temperature, humidity.
Exactly. Yes.
Yeah.
All of this can affect one way or another wind farm operations, solar operations.
Can we open this thing up, or is it off limits?
You can look at the panels,
Get inside.
the control panels right here.
This is actually a dummy. It doesn't have a laser chain in it.
Oh,
There's nothing called too spicy.
oh, you don't want to leave something like that lying around.
Exactly.
I guess the real ones cost $100,000. He said it's $110,000 is the price tag on the one with the laser chain in it. So they didn't want to leave it here lying around, on a display. So they took the expensive components and they just have like the box with this. I wish I got more of a better picture. I got some photographs of that on the other phone. So, in any case, I will have to. It's kind of like this. I don't know. It's a weird. It looked like a couple layers of glass of like iridescent glass. It looked like a bunch of layers of it that were all these circle discs of iridescent glass going down into this box. So I don't know what the heck is inside there, but they wouldn't let me look in. And they had all the components taken out. So, damn. But apparently, will they just leave these things out in the water? I mean, these you'd have to have a helicopter or something to go.
So here's another thing we've got here. I'm here with Trevor from Schweitzer Engineering Laboratories, SEL, at the 2022 Wind Power Conference by ACP. And he's telling me about some of the control systems that they build at their plant in, where is it, Washington?
Yeah, Pullman, Washington.
Pullman, Washington.
So the company was founded in 1982 by Dr. Ed Schweitzer, and he developed the first digital microprocessor relay in 1984. So we just recently crossed 40 years of being in business. But at SEL, we basically design and manufacture all the protective relays, communication equipment, automation equipment, things like that for the power system. So, cool. So anything related to utilities, industrial clients, that sort of thing, low voltage all the way up to high voltage equipment or things we protect.
So the windmill, you guys are running the whole control system that can, it shuts the windmills off, turns the windmills on, handles the power, distribution, load, all that kind of stuff. Right?
So not necessarily with the actual wind turbine, but we would be at the substation, basically that it's connected to.
You see how he politely corrected me? One guy told me, he's like, dude, they're not windmills. They're wind turbines. Windmills grind grain and they pump water. These things generate megawatts of electricity.
So you get the array cables, basically underground or underwater, that come up to the substation. So wherever the breakers are, the transformers, the buswork, switchgear, things like that, that's what we're actually protecting.
Okay.
Controlling with that. But then we've also got on the communication side, we've got like SCADA, automation, integration, that sort of thing. So operators on shore can send commands out to the substation, be able to operate the equipment, see all the data coming in, all the voltages, currents, power flow, that sort of thing.
Awesome. And people can find you guys through your website. There's a phone number there and Facebook. Here's a QR code. And what's this graph here?
Yeah, so this is just kind of an infographic here for some of the systems that we work to protect and some of the industries that we work with. So we worked worldwide.
That is huge, guys. Do you see that? 9 in 10 top global automakers use SEL power protection and like management of their plants. These guys are the industry like top dogs. 1 in 198 of 200 municipal utilities are SEL customers, right? So this is their customer. I asked him, like, what's your customers? Like he literally told me they're like PEG&G, or National Grid, NSTAR, like all the major utilities, like almost all of them use SEL. There's like, 2 out of the 200 that, haven't yet upgraded to these or don't have a need for these kind of complex electrical management solutions. These guys understand how to deliver and phase power and all that stuff on a whole another level. And their systems, like,
kind of an infographic here for some of the systems that we work to protect and some of the industries that we work with. So we worked worldwide with a lot of major companies, as you can see. And especially with the research and development side, we have a lot of engineers that are heavily involved with IEEE. And then we've also helped to develop some of the standards and work on some of those work groups to basically help kind of develop the future for electric power.
Who's like some of your top clients, you'd say?
So a lot of the major utilities in the U.S. So not necessarily GE, but
utility companies. So like
utilities would be
National Grid,
Duke Energy, AEP.
I think it's Rhode Island Energy here.
Yeah, Rhode Island Energy now. BPL, Eversource, Con Ed, are some of the ones we work with. PG&E, PSE&G. So yeah, pretty much every major utility. Most of the co-ops and municipalities around the country as well. So here in the U.S., we're definitely the majority relay provider.
Did you guys hear that? Like, that's huge. I had no idea. It's like here I am talking to this dude from the company that literally just takes care of our power grid and keeps it safe. This is awesome.
Yeah, it's awesome that they can do a lot of this with digital controls and stuff now. That's going to help an enormous amount, like being able to shut things.
Here I am just rambling. I don't know what I'm talking about. I'm gonna fast forward. I'm actually gonna show these two clips because these were the key interviews that this is my dad. Yeah, so my dad pulled me aside after I did the whole walkthrough, the whole tour, the whole thing, which is the next video. But I'll come back to that video in a second because I want to play the interview that my dad did with these guys because my dad's an expert on this stuff. So
I'm Rick Riss, and I'm here with Trevor Bentley. Hello, I'm Rick Riss. I'm here with Trevor Bentley, and we are at the American Clean Power Conference here in Providence, Rhode Island in October 2022. And I'm a market analyst for ARC, and SEL is a provider of many pieces of hardware, software, and services for the electric grids. And so what I would like to ask Trevor is, we know that you make a lot of products in medium and low voltage. In many power plants, you have a very great reputation for reclosers and switchgear and even developing software. What is it about your product line that would be appealing to the industry?
So one of the things that we specialize in is protective relays, as well as the automation and control communication hardware, and then, like I said, the software. So we've got projects that we're taking our protective relays, implementing them in GIS switchgear on offshore substations. But then we're also including the communication equipment and then the engineering to go behind the relay settings, the controls, the automation, and SCADA integration, as well as cybersecurity hardening, things like that, for all the electronic devices within the substation.
Well, that's great. So you're kind of behind the DMZ zone, so you are definitely on the control side of things.
Yeah, absolutely.
Now, one of the things SEL has done in a number of cases is come into projects where there were electrical problems on electric grids where utilities couldn't understand exactly what the problem is. You have grid scale batteries, you have EV chargers. You get into situations where there's a complicated interaction of control systems between either inverters and different entities on the grid. Some of that is harmonic, some of that is control. What is it that explain how you tend to troubleshoot and debug that and your capability to do that?
Yeah, absolutely. So we have encountered problems like that, especially at the utility scale. And so typically that will involve introducing the relays into their system, basically being able to meter things like that to get the voltages, the currents, the power factors, that sort of thing. But then also taking that information and putting it into an automation system. So we've got utility scale all the way down to industrial scale, and then basically individual customers for microgrids and things like that. So a lot of that is working with the inverter manufacturers and DER control systems, and working with our microgrid control systems.
So you can, you actually, I think, are able to interface with numbers of different single phases. That's getting the very high speed data now to really diagnose the network problems.
Yeah.
And then you also have some capabilities to do modeling and simulation of systems. And I know that I've seen at the Microgrid conference that you were presenting, hardware in the loop testing. Can you explain what that is?
Yeah, absolutely. So the first was synchrophasers. basically that's a timestamp data for the waveforms, and we're able to transmit that in such a high speed so that we can see where the power factor and what the waveforms look like at different points. And we can do basically across great distances because of the time stamping. And then we've got software to interpret that, put it into an easy to read form, especially for the operators. And then with hardware in the loop testing, what we'll typically do is we'll do our system impact studies and other sort of electrical transient studies to help develop relay settings. And then we can take those relay settings, put them into our actual hardware, and then run it in a hardware in the loop case where we're using real-time digital simulators, what we call RTDS, to play back these events and these faults and things like that to see how the relays will actually handle it.
That's interesting. Our utility recently discovered that we had an incorrect setting in one of our reclosers, and that recloser impacted when a trip occurred in another circuit, another fuse. Right? Mm-hmm. So the fuse was blowing at the wrong time, or the recloser was blowing before the fuse, and we never knew that because we never modeled and simulated it. Had we been able to model and simulate that ahead of time, we might have actually got the correct settings in this recloser and had the proper behavior between the fuses and reclosers for protection.
Yeah, absolutely. And in the protection group that we've got, that's what we specialize in is the relay system protection. And so we would do things like transient studies. We also do power system fault, short circuit studies. And so that's something that we can definitely handle. And that's working with the customer, whether that's a utility, an industrial customer. We would take the system information, model that, place faults at various locations within the system, and make sure that everything's coordinates properly.
So I've seen your equipment physically in numbers of solar fields and battery projects. Right? Your equipment is often shown in 19-inch racks and equipment coming in here. So how does that translate to the larger transmission side substations? Are you trying to basically get a larger piece of the higher voltage segment?
Yeah, so we actually have a pretty large integration in the high voltage systems as well, and it's using a lot of those same 19-inch rack-mounted relays. We also have different options for panel mounting and things like that, but there's multiple utilities within the United States that have standardized on SEL as primary and backup systems, or in some cases what we call dual primary. Well, they'll use different product lines, maybe like a 300 series and a 400 series to protect transmission lines. And so we've got a pretty large integration so far with the transmission and distribution systems.
Well, that's fantastic. Thank you, Trevor. I really think that with the amount of non-dispatchable DER, microgrids, grid interactive customers, industrial and commercial entities, the more grid interactive, EV charging, companies like SEL make that happen.
Yeah, absolutely. And part of the future is seeing, what sort of unique challenges are brought with integrating, numerous manufacturers of inverters and battery chargers and things like that. And ultimately, our goal is making electric power safer, more reliable, and more economical because it benefits everyone.
All right, thanks.
So, I'll do the big walkthrough right now while I talk about some of that. Yeah, people can check out selincorporated.com, and they have a whole education section on their website where you can get technical papers, webinars, sign up for training right here on the website, and they'll give you free training. And if you can even get a career from this potentially. So here's all right, I'm going to give you guys a little walking tour of the 2022 ACP Offshore Wind Power Conference. There are 2,000 people here discussing the future of the offshore wind
industry here in Rhode Island. The offshore wind industry is a multi-billion-dollar emerging power and energy infrastructure industry here in the state of Rhode Island. This is quite the conference.
Yeah, the Block Island Wind Farm was actually it's a $1.5 billion, 385 megawatt wind farm in federal waters, and it's a 100 wind turbine project, which could provide 1.3 terawatt hours of electricity per year.
Give you guys a little walk through. We're here at the Rhode Island Convention Center, the 2022 Offshore Wind Power Conference here in Rhode Island. These are government and industry leaders from around the world here to develop the future of offshore clean power. Coloring books for kids. This is great.
I just got it all chopped off. Market with now the hurricane resistant innovation to follow. And we have people working on the blades, but
Smile, you're on camera.
I study for this year a lot more busy. You have a lot more ages. I see 65 numbers on that side
They may be gone, you know what?
I gotta go say hi to my friend over here. What's going on, Reddy?
His name's Tom, actually, but his thing said Ray, so it threw me off. I met too many people.
Tom, right?
It said two names on his thing, so the first one I saw was Ray. I think his name's Tom, though, I'm pretty sure.
tiniest camera I've ever seen.
You guys changed colors, man. How's it going, man? I'm doing the whole walkthrough now, so people can get the whole experience.
Is your dad here today?
Yeah, he is. Yeah, I'll have him stop by. Oh, these guys with their floating wind turbines.
Yeah, no. Like that's out there.
Smile.
like my son who plays golf.
She wasn't having it.
I wouldn't do that.
There she goes. I like all these conversations.
Yeah, I'm still gonna connect.
My daughter's in college. Oh, okay.
Yeah, so it cuts off.
I'm just doing the full walk through the whole and get the tour. And these are the guys that put this all together.
Yes, me, just me.
Just you. Thank you so much. Guys, give her a round of applause. How's it going? I'm just doing the walkthrough so people can see all the booths. I have your video, don't worry.
We already showed it. We already showed it, dude. That was Mass Maritime. These guys got interviews, so. Yeah, these guys had the look at that. Let's go back. These guys had those gear core, man. These guys had some serious, survival wetsuits and stuff out on display. I wanted to put one on and take some photos, but guy seemed kind of busy, so I didn't want to waste his time. Yeah, live commentary.
Oh, no, yeah. What if, if so? Then I'll get brownie mode, but I don't think the process is
Yeah, I don't know. People are watching. This is kind of like information overload, man. There's like a ton of companies to look up here and just entities to look into in this whole scheme of things. And I didn't get a chance to talk to all of them, but I know I saw those other media people doing interviews with some of them. But I was specifically there to focus on the automation and control systems people who I talked to the majority of the time. And
Okay, well. Yeah, I don't know.
I can't miss that one. Yeah.
Yeah, we can definitely continue this conversation. I think that that's something that we have been.
Lots of connections being made there. That was a great candid moment to capture. I was a little bit off.
I know exactly.
Threw her off a little bit. Hey, there's not a lot of people here, man. I'm opening up to the usual crowd who want to talk about wind power and some of the stuff. Yeah, that's.
Serve like next door.
All right, thank you very much.
Sirens, I sent it. I sent you the link, bro. Check Twitter right now. I got it. It's in your inbox. Yeah, this is kind of boring. I know, man. It's boring, but this is like it's learning, it's education. There's a lot of vendors that were there. This is not a lot of sound, so I should be kind of talking about all this stuff as it goes. So, a lot of these were just businesses. There's insurance people there. There's solutions people that are just there's some consulting that have worked in this industry, people trying to sell their expertise and knowledge. And it's really just there was a lot of stuff missing. There's a lot of competitors that need to be.
This little DJI Mini Pocket, stabilized 4K in your pocket.
Yeah,
it's great.
The GoPro?
Oh yeah, GoPro's.
So this is the camera that I shot this all on for people who just want to break in the monotony of this wind stuff. It's a DJI Mini. I got it at Best Buy, and it stabilized 4K. In your pocket. It can track. If you set up, you can set up to do basic face tracking and some other things. So it's pretty handy. Gets decent audio, although there's not much being recorded here for audio. I wish I had more to say about all these people. These guys were cool. ISCO. They make pipe. They weld pipes together. These guys have this heater that heats it up to 425 degrees Fahrenheit, and it's polyethylene, and so they heat both ends of this pipe, and then they squeeze the pipes together and press them together, and it's this whole pipe welding system. There's a picture of this guy doing it with this big diameter pipe, and he said that he was even working inside of like 88-inch diameter pipe that it was so tall he couldn't even reach the ceiling when standing inside of this pipe, and they weld some of that kind of pipe together. And my dad said I had to come back here and interview those guys, which we showed that interview already, talking to those gentlemen. Liftex, the rock people that build those concrete rock structure form and stuff. These are the guys right here. All right, so Quintham, I talked to them, and they have this whole computer system that keeps track of all the navigation systems, and it's meant to monitor these sensitive cables, and it's set up to display that data with all known boat navigation systems. So navigation systems that get these charts as they download the data for that local area. If they're boating through there, they get this data, and these are like the guys that have to put all this data together for maritime, so that and that it integrates with every single one of these radar systems that boats have installed within the industry. So I thought that was super interesting that they can send them a file, and it takes some of them take a while for it to link up, but not more than anything more than an update for like per minute. So it gives you a good enough warning time if you're approaching, say, like an underground cable, or something that you might want to steer away from if you're a big ship and trying to navigate the waters. So I thought that was super cool as well. I wanted to interview these guys, and they were never at their booth the entire time. I went by there like a whole bunch of times and then I went to talk to the guy. I saw him outside, and he's like, "I'm on the phone," and I didn't get a chance to really talk to these guys because I wanted to ask them, interview them, because these are the ones actually, of anyone there actually building this stuff. You know what I mean? Speaking of people who actually build this stuff, what's up, Sirens?
Hey, buddy, how you doing, man?
Good, man.
Yeah, so it's kind of interesting to see you there. So I've done this for 13 years. So like kind of know basically what I do is I bury the cables subsea. So we take machinery and we actually basically we'll lay the cables and then we'll go down and bury it under the seabed, because what you don't want to happen is obviously for these cables to get damaged. I mean, it's millions upon millions per cable. So I can't talk about companies that I've worked for, but last year we put a cable fiber optic between New York and Europe, right across the Atlantic. It was the length of the cable was like 1/5 of the way around the world. So it was I've done it for a long time, but anything you want to know. I've seen a few companies, a few things I recognise there. So just whatever you want to know, just ask away.
Yeah. So one of the things my dad we picked up, I don't know if we misunderstood the guy, is that these transmission cables, like when they're at full power, that they can be as hot. They can be as like 90 degrees centigrade. Is that like just the top rating for the cable, or is that like how hot they always run? I mean, that obviously you'd have to bury it in the ground because it's like near boiling point. I mean, I can't imagine what that would do to sea life on the floor of the ocean if it's operating at 90 centigrade.
Yeah, I mean, to be honest with you, I think you'd probably more worry about with the mining. Obviously, deep sea mining is coming online now. I know some people that was involved in that, and there's a place called the Claret and Clipper Zone, which is just off the. Do you know where it's actually near? It's off the east coast. Sorry, the west coast. It's off the west coast, and it's out in the Pacific. It's like you get these nodules. It's like mining, but we're going to strip mine the seabed for rare earth metals for electric cars. So that's coming next. So that's like kind of coming up in the next few years. But the offshore wind is coming in a big way. I'm just going to send you a link. You'll like this. So I know you're into your maps. If you open that link up, that gives you, it's a global map, all the current wind farms, the ones that are in tender and being built next. And that's a company that did loads of work in Europe. So they do a lot of the laying. They do a lot of the lay work and the burial work, the actual installation, the kind of stuff I do.
Interesting. Yeah.
But regards to, sorry, to go back to your question, there is something that's came up now that what I'm more concerned about is how deep, because obviously you want to bury the cable so it doesn't get damaged, but now they're worried about it getting too deep. If you bury the cable too deep because of how hot the cables are running, because if the cables are running that hot that basically buried it so far in the ground, it can't dissipate the heat. So they actually want to bring it closer to the seabed so the water's actually cooling it.
More of a heat sink, yeah.
Yeah. So that's what they're kind of talking about now. So, but these cables are getting bigger and bigger. I mean, when I started, I'd say maybe the biggest one would be like, like under like maybe about 10 inches, something like that, like the biggest kind of cables we were putting subsea. Now, you know, you're talking like probably above 16 inches. Do you know what I mean? So, like, and we are moving power around they built a big, massive network. Obviously, you'd heard about the gas explosion in Russia and the pipeline, but we put cables in all over Europe, going between all the different countries to move energy about from all the renewables. So you're generating power in the UK, but you're not in Germany, you know, and vice versa. You just move the power around Europe, you know, along these subsea cables.
Yeah, yeah. This is interesting because I'm looking at your profile here. Because we're like, who's your guest? Well, his it's at Sirens Response Sirens at Twitter. His Twitter handle is at Response.
Yeah. I just go in there to spam stocks and shit like that in crypto, but you know, I don't use it for anything.
Pirate and engineer, I love it.
Yeah, totally. Yeah. So, but yeah, I've been doing it a long time. You know, worked in a lot of renewables, a lot of offshore wind. Like I built the biggest offshore wind farm like 2 or 3 times. You know, so I was on one. I think it was one off Wales. I was on that for like 2 or 3 years, and then there was one previously that was bigger before, and then now they're doing one called Dogger Bank, and it's a pretty interesting place because that was the place that you know, it was sort of, I don't know what year it was, but basically it was a huge area in Europe that actually sank. So it used to be livable land, but it's because it's not that deep that they're going to build the wind farms on top of it, because they drive the piles in first and then they come along and just basically the yellow pieces that you see in the T pieces, they'll sit them on top, then they'll come along with the tower, sit the tower on, put the nacelle on, and then put each individual blade on, and then they'll rotate it. It's pretty cool to watch in a time lapse. It's pretty cool.
Yeah,
So,
yeah. We're gonna get a video of that.
I'll
You'll probably be able to find those faster than me.
Stand by. See if I can find one. I think this will show you. That's 2 minutes. I'll see you just a second. Time lapse. This is like the full.
Another interesting thing people can go check out in the meantime is if you go to that wind power conference link I put in the description, and so right here, offshore wind power, and then you go to e-posters right here on the left and go to the e-poster gallery. You can get some technical, you know, e-posters on from all these presenters, and get a look at, you know, gains a ton of technical knowledge from these e-posters, you know. So, and there's technical papers as well available on here for people that want to get into any of the, you know, educational resources on here to learn about, you know, this multi-billion-dollar market share that's going up right here on the East Coast. And anyone who's, you know, nearby, this is something that, you know, is about our future. And until we can crack free energy and 0 point energy, and maybe we'll get Jeremiah on to talk about that. But anyways, yeah, my grandmother was actually Scottish, McLaughlin. So
all right,
I love the accent, and I appreciate your knowledge and input.
No, that's cool. I mean, it's you know, big fan of the channel. Followed you for a long time, so it's. I mean, it's good to come on and talk about this because it's something like I actually do know about. You know, like I mean, it's been my career for a long time. I mean, just one element of it. It's not been like, you know. I mean, there's so many different fields, you know, and I know that it's coming to America in a big way. And like I say, I can't talk about the companies, but I know. I mean, I've got some friends that have just turned up in America just now. I was on the phone to them, and you know, they are over there just now, and you know, I'm working for an American company just now, but we all knew that all the work was heading to America, and you guys are going to do it in a lot bigger way. But if you look at see the first link I sent you in the chat, the map, 4C offshore. Can you see that?
Yeah.
Yeah, bring that up and I'll talk you through some of this. So like this will load up and then this is all like, you know, it's color coding that gives you all the so like I'm just trying to see what ones have been fan it. Well, if you go down that little green dot there, see if you go back down to where you are, down there, down that one, right above you. I zoom in there. Right there. Just zoom in.
It's frozen, huh? There it goes.
The one lower below London Array.
London Array?
I just go below that. I don't know if it's crashed or not. But anyway, I mean, there's a tiny little dot just below there, and that was the biggest one in the world. That was, if you zoom in, so that one there, Fanet, that was the biggest offshore wind farm in the world. That was maybe about 13, 12 years ago.
Yeah.
That was the biggest in the world. But if you zoom out again and you can sort of see the difference in scale, like all these other projects, you know. But
if you can find it on that map, I want to go on Google Maps now and see what it looks like for GPS overview. Let's see about this. We're gonna go across the ocean. Can you see these things out there?
No, I don't know. I don't know if they actually upload the footage. I don't know if they actually.
They're not.
No, I don't know.
No, it's they don't do the footage of all the ocean.
Yeah.
They just blow it out.
Yeah. So, but if you go back to that map I was showing you, you can sort of see the scale that they were at, and then if you zoom out, like look how small that dot is, and then you come out and you start looking at the areas that like the scale of the things are built now. And to be honest with you, if you zoom out more, just so you can see Europe, if you go north a little bit, you can see these are all proposed areas that they're talking about doing. And then the yellow section there, I think that's Dogger Bank. Now this is going to be, or is it north? It's one of these. It's going to be the biggest one it's going to be the biggest one in the world. It's absolutely massive. Like the size. I mean, you look at the size of these things compared to cities. They're way bigger than the cities.
Yeah.
You know? And when you, to be honest with you, when you go out there and you see these things, if anybody gets a chance, go out on a boat tour and go and just go on a boat tour and check them out. It's unbelievable. So, you know, absolutely.
We have to do that because I'm gonna rent the fishing charter and we're gonna go out and so Block Island. Here's the wind farm. Here's the one they're doing out in Rhode Island.
Yep.
Just for reference.
Yeah.
Whew, oh wow! It's all between Martha's Vineyard and off Nantucket. So
if you have a look at like
these guys there, Vineyard Northeast, Mayflower Wind, that's the one that's already there. And Sunrise Wind. Oh wow, this is cool, man. Thank you for sharing this link. I'm gonna have to definitely post these in the description. And let's check out some of these videos he sent too.
So, but if you look at that map, it shows you all. I'm going to over the states, and you guys are going to be building the stuff. You guys are going to be building the same. You know, they're going to be much bigger than what we are building. You know, just scale wise. You know, and it's like you can see that on the maps. So the proposed areas. So you get these here. They'll come up as a jacks that sail up out of the water. These ones, the T pieces are already installed. So. You can see here how they do it and all the rest of it, you know what I mean? So they're going to all this nonsense kind of goes on, but I mean, it's like this would take like more than a day. Do you know what I mean? Easy, a couple of days or whatever. You know, they're getting more efficient now. I mean, when I used to do it when I started 10 years ago, it would take forever to do it, but now it's like they've got it nailed. It's like making a cheeseburger now. I mean, they know how to do this inside out, and they've got the people now. The people are all trained. The systems are in place. Like everything's just done so quickly now. So yeah, it's quite interesting the way they do it with the blades, because they'll put the blade up and then they'll rotate it, and then they'll put another blade up, rotate it, put the other blade up, and rotate it. Do you know what I mean? And there's obviously guys in there that I can see there the way that they set it up, and there's guys actually inside it, and they'll go and they'll actually just, they've got like massive torque and bolt kits. Do you know what I mean? You see how it's done like that?
Oh, they hold it in the middle and they balance it at
Yeah.
the center of
Yeah,
gravity.
I was gonna say that's super impressive.
Yeah.
That's fascinating. Those things are huge. Yeah, these cranes, I was like amazed at the size of these cranes.
Yeah.
This is basically a barge, and it has these long feet
No audio on this one, right?
Oh, this one had audio. Yeah, I don't know if it was
Yeah.
just, but
it's just
You know, Fred, because right now these videos are silent.
Yeah, they just got used.
Just cheesy music.
Or is it on my end?
Holy moly! Yeah, that's cool. How I didn't know that how they did it like that. But what is this? What is this system on the barge? Because it lifts it lifted the whole floating body out of the water. And now it's moored to the seafloor with these.
Yeah, so what is it's just like a jack up oil rig. So basically, those legs will just go down to go into they'll actually go onto the seabed.
It's a barge with ladder jacks.
Yeah, but what you need to be careful when you were talking about, the positions of cables. Obviously, we know the positions of the cables. The captains know they've got a footprint of like sort of like the area of the ship and where the legs are. Because what you don't want to do is put one of those legs for a cable. It has happened. Do you know what I mean? So somebody sat a jack up down, and they've sat a jack up down on the cable, and they've just wrecked it, just destroyed the cable.
Yeah, that would destroy.
Yeah.
That's like elephant's foot.
Yeah. So yeah, that's that kind of side of it. That's not really my job. I'm never involved in that. The next video I sent you, that's more what I actually do. But this is like that kind of there shows you the monopiles, and there's a lot of different companies that's doing this, so it's, I know that I mean, like Rostock have been there, Rotterdam, that'll be this very second place. Beatrice, I know some of the guys that was on there. But the industry is quite small, to be honest with you. There's not like, it's a lot smaller than you think. It's like everybody sort of knows everybody. It's it's going to get bigger now. We know that the guys are definitely hiring in the States, and we know that once you guys start doing it, you're going to be doing it in a big way. It's just because everything's already set up. The contract's already signed. Because like you can go online and look at those maps. It tells you where the contract's signed. You can go and find out all the information, all the companies that are doing it, who's financing it. Everything's there. It's all public. It's all very public. These are a bit different, these ones, but you can see that gimbaled kind of leg or whatever. But they do a kind of thing where they'll basically set the pile in, and they'll either smack it like a hammer, like putting it in like a nail almost, or they'll do it with like a suction, depending on the ground, and they'll just basically vacuum the tube, and the tube will just pull itself into the ground.
Yeah.
And obviously they're doing like laser, like kind of welding and cutting and whatever. But that's like these monopiles. That's what.
Yeah, that's too sturdy with they're just on 3 hydraulics. Those tiny hydraulics looks a little undersized for the size of that rig. And I was just like, yeah, well, there'd be better ways if you just put vacuum on the feet to suck the dirt up around it, so it could embed it into the seafloor a little bit better.
Yeah, that's what these are here. So they'll set them up, and whether they vacuum them, they'll hammer them in, but because it's like they literally pile them in like a nail, or they'll vacuum them. So aye. Aye. So yeah, there's a lot. Obviously, like a lot of stuff I do is more like kind of remote submersibles. So you've seen the little, ROV that was down there. Like I don't do ROVs, but I'll show you some of the stuff I do. Yeah.
Yeah, maybe try to rejoin, Jeremiah. I can't seem to unmute you. Then they get the pile driver and drive these
Yeah.
in.
Yeah, but these are 24-hour ops, so it's like imagine trying to sleep in that ship when that's going on next to you. Do you know what I mean?
Yeah, 24 hours, right?
Yeah, 24 hours.
Let's give a quick mic check. Sorry to disrupt.
Yeah, we can hear you.
Okay,
spot on.
it's working. Yeah,
So
I
you
lost
had-
my connection. My whole connection just got taken down for a moment, but it's back.
So
Sorry.
that's what you're saying, man, is that you had to sleep on a ship while this is going on 24/7.
Yeah, I mean, some ships are better than others. You know, it depends like how good the soundproofing is or anything. But it's like
Yeah.
but it's no, it's cool. As somebody says, it's a cool job. It's definitely a cool job. Do you know what I mean? It's a lot more, it's a lot more interesting than a lot of other jobs. But yeah, I think this is them showing you how they're going to do and put the substation on, because obviously that substation it does. I know Jeremiah would be all about this, but like a lot of conversion. I'm not going to talk into the exact power conversion. Do you know what I mean? Because it's like they've got different systems, and I'm not going to butcher it by saying the wrong thing.
So that's how they just use that guide to drill the piles in for the foundation. That's pretty neat.
Yeah.
Yeah, it's a little sad. I missed a lot of your explanation there, and I'll have to go back and watch it because it's firsthand evidence, firsthand experience. So that's way awesome. I've worked with a lot of these heavy power cables, worked with substations, installations, and even retrofitted power plants. So we've seen some of this heavy distro equipment. It's pretty amazing stuff, honestly.
Yeah, I mean, it's amazing. It's amazing to get into. Do you know what I mean? I definitely say if somebody was getting a bit younger or whatever, I'd say, it's a great thing to go. And this company's a cool company. This is like, so this stuff here, this is like basically, this is what buries the cables. So this is like,
oh wow, look at that! It's like a plow. It's like a.
That is a plow. That is
cable plow. Yeah.
So that's like all the kind of stuff that they use for like kind of that's the kind of work that I do. So yeah, so that's the kind of that's basically my job is like kind of basically either a technician or a supervisor for these systems.
Nice. Yeah.
Yeah.
Even on service level cable installations, like say you're an electrician and your job is to wire power from the home circuit in the basement breaker panel to the garage, there are things called ground diggers or trenching machines, and they'll dig a slot into the dirt. Only about a foot to maybe 2 foot deep at the maximum, but most of them only go about a foot deep. And those are some fairly complicated machines designed to dig through dirt. But this thing, now you just multiply the complexity by tenfold. You've got what we're looking at right now, a machine that can do all the ground trenching stuff deep under the pressures of water, minus erosions and all the other problems that it would face. It's really an amazing technology.
I mean, it's pretty cool. Like I always think it's probably like I mean, obviously you guys are like a lot more kind of space focused, but I think it's the closest thing on Earth you're going to get to space. Do you know what I mean? Without actually going into space, like the environment down there. Obviously space has got other problems, but it's like this is probably as close as you're going to get.
Just say we're going to do the moon bases. There's an old NASA document. It's from the 60s. Talks about how to install proper cabling and communication for moon bases, and it is a prerequisite, a requirement to bury the cables pretty deep, at least a foot or more, to avoid micrometeorite impact and destroying the cable and communication. So yeah, this technology would still be needed even on a external planet or external small body of mass.
Yeah, well, they've got systems like this. They've got other things that are sort of tracked. That's more like track systems, like what you were talking about. Like it's more like a cutting chain or whatever. There's a bunch of different systems that we use. One that's more kind of fly about like an ROV. This is just like a plow. But I thought like nobody knows anything about this stuff. Do you know what I mean? It's like nobody's seen this, but this is like what we actually do use to go and like put the cables between the wind farms because you need to be buried. Do you know what I mean? So it's yeah. So yeah, it's
And what are these hypersonic jets of that blast the sand and ground debris away?
Well, it's like water pressure, so it's like maybe like 7, 8, 9 bar, something like that. It's not crazy pressures.
Not crazy.
No, it's not like
water jet.
Yeah, I mean it'll just sort of break it up a bit.
Rocks though.
Well, that's the thing, because it depends whether you're doing something that's like more chain cutting, because you might do something that's like a chain cutter that it's got like jets and stuff like that at the back, but then you'll do other stuff that's more jet cutting. Do you know what I mean? So
So with the water jets that basically blast through the sand, stone, and rubble, are these pretty much like laminar flow high pressure jets, almost like a pressure washer?
Yeah. I mean, it's nothing special. Like, I mean, obviously the motors and stuff are quite specialist because you're running high voltage down, and obviously, you get the problems you get with like high voltage and motors and transients and stuff like that. There's been a big problem in the industry that's been to do with basically transients, kind of high voltage VDCs.
Yeah, we're talking about that because some of the DCs only have one wire, and they try to send the return through the ground, and that causes a lot of disruptions when you pumping that much current through the ground.
Our stuff is like the stuff we use is free phase, but it's like the free phase stuff was like basically you were getting like how you get like a VSD, you get like the step function. Do you know what I mean? But obviously it's smoothed out. But when it's heavy power, you were getting transients, and if you're putting transients for HV, if you're putting through transients for like HV stuff, you're obviously can damage the lacquer or yada yada yada. We could go on about it, but it's a bit kind of,
Yeah, this would be 3-conductor shielded HVAC.
Yeah,
not
yeah,
air
so
conditioning,
that's right.
but
Look at that cable.
All right.
That's the friggin' thing on that boat that has the big turntable.
Yeah. So that used to be my job. Was I used to control these
That's
machines?
nuts.
Yeah.
Just look at that stuff. I mean, that's bonkers.
Good
Lord.
Lord.
It's like miles long and huge.
Yeah.
I mean, it is beautiful in its own right. Just seeing manufacturing produce a continuous, unbroken, water-sealed length like that. I mean, it is kind of amazing to think of that as pretty much the biggest spool that has ever existed and ever will need to.
Oh, that's the size of this plow?
Yeah.
Look at that, man. That is nuts, dude. That is the biggest spool of wire anybody is ever going to see, period. I mean, that is tremendous.
That's a lot of copper.
Yeah, I mean, it's like that. That you need to think as well. The amount of money that gets invested in all this to do this, it is billions. It is billions. And it's like, but this is like all these projects have been lined up for 5 years. So even if we go into a recession just now, this work's still going to continue because that money was put there 3 years ago, 4 years ago, 5 years ago before COVID. Do you know what I mean? Like this, like that those industries are still going to be going because they plan for this kind of stuff. And it's the money's there.
The only thing that's really, I think, more shocking and amazing than the ability to lay these kind of underwater cables, dig through everything else that's underneath and protect them, is the repair process of what happens when one of these things gets damaged. And that is amazing in its own right because they've got robots that go down there, seal around the entire cable periphery, inflate the entire thing with air so that a welder, a human being, can actually go down there in a diver's suit, weld that thing, fix it, and then, evacuate all the atmospheric air.
Well, they do.
My brother-in-law is an underwater welder, and it's pretty intriguing to even hear some of the stuff that he's worked on. It's an incredible, I guess you would call it a trait, but yeah,
it is. It's incredible. The fact that we can go down there at such high pressure and do these kinds of complex operations in an atmospheric environment, it's pretty freaking awesome. And the machines that are used are so complex and so sophisticated. It's really almost overkill, but really, if you think about human safety, it's not really overkill at all.
Engineering that goes into it, it's amazing. Yeah, to keep it, and the workers that work on this stuff are just,
I mean,
underwater welder pays, between, what was it, 10 years ago? I looked at the trade. benefits, and it's like 100 to 150,000 a year. That was 10 years ago, so who knows what it is now?
Yeah, but you put your life on the line every day, I guess.
Every
But,
single day.
you know, and then the other thing is too, and I think somebody just mentioned it. I can't remember who, but you know, we're gonna have 5G. You know, surgical technologies that are instantaneous. You can send a robot down there that can probably weld with no human life at risk, and then you know it's just that much easier. So you know,
Building
you
the
might
robots.
eliminate jobs, but yeah, it's interesting for sure.
That's been heavy in development for quite a number of years. I mean, the idea of replacing underwater welders with robotic machines and having those same fellas that already know how the welds look and how they work basically control the robots has been a major implementation. But unfortunately, the robots just they haven't been capable of performing the same quality of work, and there have been major issues where divers still had to go down and fix the robots' mistakes. That's been an issue. And a lot of companies have just simply erred on the side of using humans because they know they're going to get a guaranteed successful job, where the robots tend to screw up and there are other issues they can't fix from the surface via cable.
I mean, what
We'll get there. I mean, we'll get there eventually for sure. But for now, we're definitely not there. We still need people to go down there because our machines just aren't good enough. And companies that are doing this kind of operation, they tend to not buy the best machines in the world that are actually capable of doing this.
Oh, so they towed this thing back off the ship towards the land first.
Yeah, this was a bit of a unique job. This was a bit different. This was sort of kind of something a bit different. This one, but the going back to the stuff about the pipes and that. I mean, I do a bit of oil and gas, not really that much, but obviously like the pipe that just get blown up and off Russia or whatever. But they do go, like as you were saying, they do go down and they will sort of like as you Jeremiah was saying, like we'll go down with a habitat, build the habitat around it, then take all the water out and then weld in situ. But with cables, they just cut it. They just cut it, pull it up, and then just join it. Like just get and then basically just lay it off the ship again.
Yeah, and that process of joining it is an incredible skill on its own. I mean, it takes years of training just to learn how to join these cables because the process is so ridiculously complicated. I mean, there are 7 layers, I think, to some of these cables, and that's for the basic power cables. If you go fiber optics and communication, there can be over 1,000 layers.
They've all got fiber optics in them. Every one of these cables got fiber optics on now.
That tube is that like an inflatable tube that floats it?
This is basically when they're floating the cable out. So what they'll try to do is basically laying the cable off. I mean, that's how slow it moves. It's very, very slow how slow it goes. But basically, so they'll do that. They'll pull it all in, and this is like a beach pool kind of situation. So basically get pulled in and pulled up the beach or whatever. And then this would be the cable that they would then plough this out to. I mean, it could be a different country. It could be like a wind farm, and then they'll take the other end of the cable to the wind farm and basically send that back up. I know that Simon. I'll show you this. Simon just talking about something there.
Simon, join the. I posted the link. I don't know if you saw it.
It's far easier to destroy these things than it is to lay them. It's not that difficult to go down and wreck them. They have been damaged, and people have had to go down and repair them.
Yeah, so. Big ships have run into them and stuff too. Yeah.
If you look
and then we got geological movements, right? The number one threat for a lot of these transmission cables and communication cables is these geological motions. They get stretched and stressed.
How does it drop? Oh, what is that? It's just flipping around. What is that?
So I'll show you. See if you go to see the link that I just put in, the other one, in the StreamYard. Check that out. Because just when you're talking about these cables, and I can't go into too much detail about this, but what I will say is this boat that's in the chat link and the StreamYard link, this one here, basically we were doing a fiber optic job, and they came and basically came to spy on us. Do you know what I mean? Because you know, it's aye, but they, you know,
we're a research vessel.
Yeah,
with the fiber optic stuff, it'd be awfully hard to infiltrate inside of that cable.
Yeah.
You think if you tap it, you would lose signal integrity or something like that.
Well, I mean, I know, but there's been some discussion about that because I've heard different things. I've heard that's just not true, but then I've heard other people saying that it is. Do you know what I mean? But I don't like you know, because I do know a bit about the you know, the subsea telecoms. I've done quite a lot. I've done it like for Huawei. We've done a fiber optic network. It was like 2.7 million meters of cable we put around Indonesia. It was 4 months just going around Indonesia, and you know, so it was like, you know, but that was for Huawei, you know, the Chinese phone company that got banned from America.
Oh yeah, and you did say 2.5 million, right?
I think it was at 2.5 or 2.7 million meters. So it was basically sort of like 2,700 clicks or something like that.
That is an insane amount of cable.
Yeah, but I mean, these things wrap around the world. I mean, you can let's see if I can find the, like, if you go and look up the subsea cable maps and all that, you know what I mean?
I guess I've never looked at the neural network of our communications through overseas deep cables. I've got to imagine that network is pretty interesting.
Island.
Sorry, I'll just look that up.
Holland, Block Island, and then coming back to the main the shoreline, the main line at Point Judith.
That's probably quite a good one. So
yeah, Cosmic Dave's kind of saying the same thing. If you try to tap a fiber or interact with it in any way, you're basically going to lose your signal integrity. It'll have issues. So I'm not sure how that's not true.
yeah, I mean, I don't know. I actually read something. Now I don't know if this is true, right? But like, I mean, we all know that there's technology that we're not all aware of. But I heard that they could tap fiber optics without breaking into them.
Yeah,
now,
I suppose
I'm not saying it's true.
Use.
I'm not saying it's true, but I'm saying that someone said I read somewhere or someone told me that they can tap fibers without breaking into them. And how they do that, because it's like, it's not that you get an electromagnetic field or something like that. Do you know what I mean? But
right, well, like on the surface of the between the inside and the outside jacket of a fiber optic cable, you have this strange phenomena called an evanescent wave. It's
right.
This traveling wave that only goes along the surface and very narrowly penetrates about a quarter of the wavelength into the outside jacket. But yeah, I suppose if you could monitor that, read it, you wouldn't really degrade the signal quality all that much, because it would still be trapped within the refractive index of the inside cable. But you could theoretically read it as long as you had a system that didn't load it much.
Tune the refractive index of the whole cable with the low injections, get it.
I'm sure if you spent enough millions of dollars on a program to specifically do this, that any government really could probably figure out exactly how to do it. So I guess I got to take it on that, Sirens, that I'm sure it's possible. I'm sure it is.
Yeah.
Might not even cost as much.
It probably doesn't cost.
Throw a location out in the chat if you think there's offshore wind and you want me to go look up a wind farm on here. I'm on this really awesome map that Sirens provided, and I'm looking at all the proposed wind farm locations. And I want to see what's on the west coast here.
Right, I think it's up north. Like, you need to leave it load up a bit and then it'll kick in. So there's one just down a bit.
I don't see nothing up here in Alaska or the west. What's going on? These Cali people don't want wind. All the San Francisco. No, there's got to be some.
There's got to be someone down there.
Oh.
They don't want wind. They got too many wildfires out there.
I need to give it a bit longer to load up though, because it's not very, it doesn't even load very quickly.
It's a bad joke.
Yeah.
I don't, or maybe it's not loading. You think? I just read.
Yeah, there it is. I think you can see it up there.
Oh yeah, Portland. Yeah. I know there's some up in. Oh, look at all this now. It's loading. Oh yeah. Olympic wind. Interesting.
So the other one is, but I mean, there's a lot of interesting stuff that kind of happens around this. But like, I mean, it's going to be huge. I know that this isn't really the normal stuff we talk about in the channel or whatever. But like, just when I seen you talking about this, I was like, I'll need to jump on. But yeah, I mean, it's definitely like, I mean, it's good money and stuff like that. You know what I mean? So it's not like it's better than a real job. But I mean, it's going to be massive in the States. You know what I mean? These are just the ones that's announced just now. But like, you need to think of the scale of these things. I mean, Americans, look at the size of that.
I didn't realize how big it was over in the UK, but this map just shows it. I mean, look at that. It's just dwarfs it. The wind energy that's going on over here just dwarfs. Again, yeah, they said Denmark. A lot of people from Denmark and Germany. So right here is this is it.
I was in the Baltic Sea a couple of years ago. We done a job up there, Krieger's Flak, and then what happened there was when they were making that, they actually ploughed through a Viking ship, and they recovered. They basically recovered. Well, they went down and basically, it was the remnants of an old Viking ship that had been exposed because we went and basically ran through it. So they went down with ROV and took photos of it. It's in a museum now.
I wonder if these guys, I want to talk to the cable guys, because what about if they got this much power? What about microwaving it back? They like, like these cables and stuff. It seems like if you could build like these, microwave relays, you could just beam the energy back instead of having to lay all this cable.
I don't think they've been efficient enough.
That's kind of where I almost want to interject here and just mention even Starlink, and I think Elon Musk is a not exactly a pioneer, but you wonder what Starlink's really doing up there.
You know what's really amazing though, if you take a look at that map of the wind farm, I mean, what's incredible is how little actual square footage space it takes up on the surface of Earth compared to how much energy is generating, and then we can kind of see just this is what we can do with already flowing currents produced by nature, and there's just so much power in the atmosphere and the wind and just about everywhere we look, but we are not using atmospheric power, and that's because we don't realize how almost unlimited that resource is.
I'm trying to find. I'm just trying to get one. There's these new ones. It's just out. I can't remember what the biggest one is just now. The biggest in the cells, so the cells the bit in the top, that actually produces the energy. This is all the subsea fiber networks. That basically just basically that is the internet.
Oh wow! Yeah, this is the mostly people think it all goes through satellite, but it actually goes through undersea.
Yeah.
Way more effective than satellite.
Yeah. I mean, it's just. I mean, there's fleets of ships out there that just maintain this stuff. Do you know what I mean? So there's like thousands of people. That their jobs is just to basically make sure that this stuff's left operational. Do you know what I mean? So.
Yeah, they talk about all there's companies out there that just do emergency response and cable patching that they have services to do that. But one of the things they were talking about is some of the locations they try to build these wind farms or some of the locations where these cables are, like for example, right here, Cape Horn in
Yeah.
Africa, there's
Yeah.
maybe a couple months out of the year you can actually work on stuff.
Yeah.
If there was a break. So
Yeah. I mean, the other thing as well is, you know, up the east coast of Africa, it's like pirates. You don't think pirates are real? Pirates are fucking real. You know, like kidnaps a big problem. You know what I mean?
yeah.
And it's like, you know, so it's like I know that round there they don't really mess around certain areas. They don't even bury the cables. They just go fuck it, just freely it out because you know it's like too dangerous. You know, just because obviously, you know, these people that's you know from wherever are like desperately poor. Do you know what I mean? If they can sell you for £1,000,000, do you know what I mean? It's like a good payday for them. Do you know what I mean? So, but no, I mean, it's a cool job. Definitely, like the fiber optic stuff, super interesting.
You have to have a security force on board when you go out there and do work on stuff, and it's like that's just adds just the cost.
Absolutely, and since
Reminds
this is
me
sort
of
of part of
Captain
national
Phillips.
infrastructure, like you would think that because it's an infrastructure supporting system, world militaries, especially those for communicating countries that are putting these cables between themselves, would be more than willing to support the process of this happening and make sure that that kind of stuff didn't happen. I mean, you would
That
think.
implies competent governance.
Yeah.
Well, it also implies competent companies who strong arm governments into saying, if you want us to do this contract, these are the support networks we're going to need.
I think you nailed it perfectly, Jeremiah. that was perfect.
You can't count on governments to be competent, but companies are profit motivated, and, well, quite frankly, they do know better because they lose profit if they don't know better. So they've got this figured out pretty well by now. But yeah, it's still a problem. I mean, if you go out there and think that there's not going to be any kind of issue with pirates, literally, you definitely have to compensate for it in a lot of these areas.
So these all go into New Jersey, pretty much, in New York, according to this map, like Long Island.
Yeah, I mean the reason that a lot of them go into New York because have you ever seen the movie Hummingbird? Is it the Hummingbird Project? Basically, it's a movie about putting in a fiber optic cable because what they do is, you know how you get quants and high speed trading. I don't know if you know about this stuff. So what it is, so basically it's like high speed trading systems and algorithms that's basically, you know, constantly in the stock market trading. If you can get like a microsecond quicker, you know, for your system. So they try and lay the cables as straight as possible. Like I know that the London Stock Exchange and the New York Stock Exchange get their own cable put in across the Atlantic just for them, for no one else. Their cable.
Yeah, I suppose we were expecting to see something that looked like, neurons or connections like that, but we're really looking at something that looks more like muscle fibers because it does make sense that they should be straight, that you should get the lowest communication time in a straight line path between these.
I think you're referring to neurotransmitters, and I think let's say you have control over those cables and you can intercept what's going through them. You would have the advantage over anybody on the stock exchange or anybody anywhere, to be honest.
But I mean, yeah, Siren is dead right though. The straightest path between A and B is pretty much going to be your most effective, lowest millisecond communication terminal. And if you can reduce that down by any means whatsoever, and this comes down even to fiber optic cable technology. Great many deals of fibers have slower communication speed, much lower than velocity C, and sometimes 0.996, 0.95. If you can get that up to 0.99 or above, then you're really dealing with something that's going to give you that fast durability. And I'm sure that these things have very high value placed on them, especially for fast communication networks.
I mean, where all the money is now, the technology is in the head units. I don't really like the receivers and the transmitters, whatever they're called. But those head units, that's where the technology really is because you can put the cable in and you can always use, you can just keep changing the head unit. So you're just coming up and just changing the rack. Do you know what I mean? And that's it.
That's so dang on true.
On you go.
And they run fiber optics through these as well as power and a number of other things too. When they lay the wind cables, I've seen. I was talking to some of the guys at the thing today. So this is Wow, quite a network.
Yeah. There's a lot more planned just now because you've got to think there's obviously a certain limit to the amount of throughput from it. So, you know what I mean? That's sort of like, it's just obviously the amount of throughput that you actually get through it. Do you know what I mean? So how many more cables they need that they're building? Do you know what I mean? To just, because I mean, it's not like the internet's slowing down. It's not like we're using less data, unless it's kind of going a bit off topic. Do you know what I mean? Talking about the fibers, but I find this stuff more interesting than the wind actually now.
Yeah. Even on the right side, we can see the kind of precision that this map gives us for all these cable lays. And on the left side, it looks like they're, taking sudden turns. People might think that's a graphical representation. No, that's literal. That's how they mapped it out GPS-wise. Moved these boats, laid the cable in exactly like, these fashions and made these sharp kind of turns because it was more mathematically suitable. And they can easily calculate out if there's an error there using these kinds of geometries.
Well, there's also, topographical data and undersea topographical data that's not included, in this.
Yeah, I mean that's like the routes are more based around the topographical stuff.
Yeah, and for all the cables that we're seeing, I mean, there are probably twice as many, just considering military and government-laid cables that are totally off the maps that we'll never see.
Yeah, and because I bet you there's teams that go out and try to cut in and tap into these and splice off them, too, as well. It's like it would seem like to me like a good source. It's like what the NSA did with that room at AT&T, I think it was. I'm not sure.
Yeah, no, I mean, Cosmic Day was basically arguing against the idea that you could possibly tap a fiber optic cable without setting off the transmitter or the receiver end, because they do detect errors and they will flag. But
I think
a momentary flag could happen for quite a number of reasons, and so as long as it's short-lived, I mean, it's technically possible. Yeah, maybe a flag will come up on somebody's end, but as long as the thing continues to communicate, you could still theoretically tap the evanescent wave. And what are they going to do? Try to sail the entire length of the cable and find out exactly where this tap is? If you mask it well enough, if you hide it well enough, camouflage it, you won't ever find it. So yeah, they might know that it's being tapped, but unfortunately, I'm sure that every country knows what every other country is doing. And if we think anything other than that, we're probably just being morons.
Well, and I think that's when you have to, from a government standpoint, for communications and military standpoint, you have to go to a full quantum. You have to go to a quantum communication device, and whatever that is, I'm not sure. But I think that's really, at this point, the only security that you'll have in terms of talking to one another.
Point-to-point quantum entanglement.
Yeah,
I would have to agree. You can't disrupt that without disintegrating the signal, so there's no way to intercept.
Well, we a lot of the guys in the industry are talking about that now because we know that the quantum internet is coming. You know what I mean? It's like, I mean, there's a lot of people working very hard on it. Do you know what I mean? So it'll come eventually. Whether it's in my lifetime, I don't know yet, but it'll come soon enough.
I mean, yeah, right now we send electrons and photons down our cables, but we have no idea what we'll be sending down them in the future. I mean, we could be sending impulses. We could be filling them with liquid nitrogen for superconducting cables and communications. Who knows?
Yeah.
We would have never thought 30 years ago that the internet would take over the world like it has, or that we would lay these massive, massive intercontinental cables. But here we are, and where we're going to go from here, I mean, the sky's the limit. Well, and so is under the ocean. There's no real limit.
I can't wait to see where we're able to send more kilowatts of power longer distances than this, because these wind farms are going to be quite serious. If they beam them back individually, and then you'd have to make sure that birds and other stuff. I mean, think about that with microwave birds.
Well, again, when it comes down to birds and all these people worrying about wildlife flying into giant turbines that are just absolutely massive in size, I get the concern. It's not actually a valid concern. I mean, it's an absurd thing to even point out. But okay, let's pretend we're not going to do this anymore. Let's stop using moving part systems. No more turbines. No more big blades. The atmosphere is pumping out so much energy. It's freaking unbelievable. It's just unbelievable. 400 million watts continuously pouring down because we're not using it. But here's the thing. What
This is
controls how many positively charged particles coming from the sun hitting Earth actually reach Earth, and how many are deflected off Earth's magnetic field? Well, here's the funny thing about that. The amount of positively charged particles coming from the sun hitting Earth is dependent on the Earth's upper atmospheric or ionospheric charge potential. And if we use the ionospheric charge potential in the way that Tesla had intended to tap, where we start actually pulling power down and giving the ions in the ionosphere a path to ground, where they would like to neutralize, there's a gap left behind that process, and more positively charged particles from the sun can flow in and fill the gap. So even though there's 700 million watts, or excuse me, yeah, I said 400 million originally, I'm sorry, 700 million watts continuously flowing down, that's a fraction of what's actually available. We could get many, many, many gigawatts continuously if we use the power, because now there's a scalar potential gap and more particles can flow in, and they will fill the gap because they're being pushed outside the atmosphere right now, and they already would like to get in. It's just that the scalar electrostatic potential is too high. So yeah, the amount that we can tap out of there is more than enough than our society uses. We just simply aren't using it because it would require very large transmitters and receiving stations.
Hey, Jeremiah, can I ask you a quick question because you're so knowledgeable on
I
stuff?
doubt it, but try me.
I think you're pretty sharp. What are your thoughts or ideas on HARP and what the heck it's actually doing there in Alaska? I'm just very interested to know.
To start with HARP, you gotta understand the concept of phased arrays.
Right.
Metamaterials and phased arrays go hand in hand. I mean, they are effectively the same thing. Metamaterial is like a tiny little phased array that responds to a received input waveform. So that's all about the UAPs and the UFO thing. It's all about propulsion. As far as HARP goes, they have the ability to produce a variety of phase signals, and each one of those microwave transmitters can independently be controlled by a system that those are independent, effectively consider them independent. Processor system, or a phase controller, properly called, will tell each of those what their phase delay is so that they can determine where the nodes and the antinodes of the microwave transmitted signal will arrive at the upper atmosphere. You know, we've already seen plenty of videos of HARP pushing the clouds up and pulling them down, or producing strange auroral effects. I mean, after all, it is the High Altitude Auroral Research Project. So, of course, they can produce auroras, and that's been videotaped by a lot of just onlookers. What can it do? Well, if you can push the atmosphere up and down, and you can deliver enough energy to effectively control where the energy is concentrated in the atmosphere, you have power over the jet streams. If you have power over the jet streams, then if natural phenomena is occurring, you could modulate it and take advantage of the already present flow from our thermokinetic energy input, creating all of these wind motions over the planet's surface. And you could create storm systems or destroy them. You could redirect very large storms like hurricanes. I mean, there's a pretty big limit to what you can actually do if you have enough locations. And, well, does HARP have enough locations? Then that's the question. Yes, the answer is absolutely yes. They have a lot of locations. I'm not sure exactly what the number is, but last time I checked, it was over 50. So you could control this kind of thing. What are they doing with it? That none of us know.
Yeah, I thought that would be a just kind of an interesting topic for the audience too, just to kind of get your perspectives because you're so knowledgeable.
Well,
so,
I can tell you what it can
thank you.
do based on its power output and based on the way that it's been laid out across the grid of the entire world. I can tell you what it's capable of doing. I can't tell you what it's being used for. Just know that it can control jet streams and weather patterns.
Thanks so much for that. I appreciate it, and sorry to hijack the stream here. So
yeah, no problem. I mean, it is kind of related, right? I mean, these wind turbines rely on all these currents anyways.
little bit.
Funny thing is, if you wanted to make this relevant, yeah, HARP could actually create more power from some of these wind turbine sites.
That's kind of where I was going with it, but I'm not too smart to relate everything. So thank
I just
you.
want to bring it back to kind of the topic of this. You know, it is about wind energy and about new alternative solutions for energy. So yeah, you could use it for that theoretically.
Huh, that's cool. Have you heard about this? This solid state wind turbines, bladeless. This vortex bladeless.
Yeah, these are cool, man.
Yeah.
This is a really good idea.
Yeah, I never heard of these before. I mean, this is certainly.
Yeah, it's basically a lifter but backwards.
Yeah, it's like a lifter but backwards.
Exactly. Actually, Thomas Townsend Brown, and you could pull up the patent for this, Jeremy, if you wanted to show how these things generated power. T.T. Brown has something called a ionic microphone.
And how about the guy that built one of these kind of things on his roof and got like arrested by the town? Or
I remember that case. Yeah, he ended up having to build an entire enclosure over the thing to make it look like a normal roof, and just having these vent holes in the sides. But he was able to get away with it, and from what I understand, he's still running it to this day. He just had to build something over the top of it so that nobody's seen anything moving.
Huh. Crazy.
It's stupid, dude. People just don't like people doing their own energy solutions. I'm sure it wasn't the town. I'm sure it was some paid energy coalition or something on those lines.
Well, anyways, I don't know. I don't have much more to show about the wind conference, and this is kind of what the thing was about. And thank you for the links. And Cyrus, if you got anything else to add, where people can find you, anything to plug.
Nah, man, I'm all good, man. I'm just bouncing in. I'm not looking to be an e-celeb, so.
Thanks for sharing the knowledge with us, and there were lots of interesting things I learned from you, and this link is super cool. So
yeah,
I got to be honest, that was probably one of the coolest descriptions of his expertise. That was awesome. Thank you.
No problem, guys.
This is really neat, man. Thanks so much for coming on. Just to see all these sites and to know how to look at them, and seeing how little space they really take up. I mean, it's kind of incredible. But we could generate so much power from such little amount of volume of surface that we're already not using effectively.
I mean, for me, it's really tidal, but tidal's just not. It's not there. We don't have the. The problem is it's really the maintenance side. We can put stuff down there that generates power and stuff like that, but it's like the whole operation that goes and having something subsea with moving parts. It's like,
it's so corrosive down there.
Yeah, totally. So it's like and the thing is as well, it's unbelievable how dirty things get under the sea. So like even cleaning it and stuff like that, So it's like I would like to see tidal, because the amount of energy that's in the sea is just phenomenal, and that. But like, to be honest with you, people talk about solar and everything else, but if we could get our shit together with the tidal, that'd be a total game changer, because it's what it's doing. You've got all planned, you've got all the tide tables and everything else, so it's like it's just gravity.
Oh yeah, I completely agree. You're not going to get anything more reliable than gravity. Yeah, there are going to be storms. Yeah, your system has to take 500% load at certain points, because there are going to be big wind systems, big storm systems. But if it can handle the kind of extra load, or if it has a way to shut down or lock up and hold its position under those kinds of load conditions, the amount of energy that's continuously available 24/7 just from knowing tidal currents, because gravity's not going to suddenly shut off on us, it's way more reliable than almost anything else, except for maybe geothermal.
Yeah, totally. But no, it was good bouncing on and speaking to you guys. But I'm gonna jump off, man. But good chatting to you.
Yeah, absolutely, man. Hey, I'm gonna take everyone off just for a second, and I'm gonna close down the stream. Thank you guys all in the audience, and everyone who joined, and everyone in the background, everyone who didn't join, everyone who just hung out in the chat, and everyone who's just hang out there quietly and didn't say anything. I learned a ton of interesting, cool stuff. Conference today. Got a lot of cool swag, as I showed at the beginning. I'll show it again real quick. My hats. I got a pair of socks from the shipping company, and I met a lot of cool contacts. So who knows? Maybe maybe we'll see what's going on with this in the future. I don't know. It didn't seem like people were super interested in this topic, but it was something a little different. Good to switch gears, and thank you for all of us who appreciated the info. Take care. Till next time.